All right. Good morning, everyone. I'm Amir Rezvani with Infratek Solutions. Infratek specializes in automated NDE of bridge decks. This presentation is more of a report out, and I would say kind of creating awareness about this research sponsored by NCHRP that we are currently working on. And as the title says, our focus is in the early ages of a bridge deck post-construction. Pretty much we are looking at first 3 and 4 years. So here, as Dick just mentioned, that is the title of the research. We are aiming to establish NDE metrics so that they would help us with kind of quantifying and formulation of what the condition of the deck is within, for example, 2-3 years post-construction, when most of the time, if something is happening to the bridge deck, if it is cracking, if it is taking in moisture, most of the time, us as inspectors, we may actually overlook them, or we may not pretty much see them because we don't have like the right tools to, for example, see that area of hairline cracking forming, for example, at one side of the bridge deck. So the research is actually sponsored by NCHRP and managed by TRB under NCHRP IDEA program. And the way that TRB and NCHRP define this kind of research and this kind of program is the proposals are innovative concepts which, if proven feasible, have the potential to significantly advance the state of the art and practice of the nation's highway system. So we received this grant, we won it last year, and the work pretty much began January of this year. As soon as we got the award, we formed a very good advisory committee. Folks from Delaware, Wisconsin DOT, Philip is actually here. Joe from Iowa DOT is actually sitting in the back. A few other folks from Vermont Agency of Transportation, and also Mr. Bruce Johnson, who was the state bridge engineer of Oregon and very involved in AASHTO for quite some time. They were all part of the advisory committee, and we were very fortunate to have them. So some of the project goals that we are actually following are, as I just mentioned, the primary focus is the first few years of the bridge deck post-construction. And as Dave just mentioned, we know that bridge deck is pretty much just like the roof of the structure. And we want to make sure that we study it, we inspect it, and we take good care of it literally the first day after construction. So what we are looking at is, through this research, we want to produce, as the second bullet says, early age vulnerability detection and quantification system. So pretty much come up with a system, and by system we mean both a system that is capable of collecting the data as well as a software system that is able to actually ingest and take in that data and formulate whatever the data tells us, to give us what we have actually called a vulnerability plot and vulnerability index. So the thing that we have actually defined as vulnerable is areas of the bridge deck that, for whatever reason, most probably because of hairline cracking that is happening post-construction, have started to actually take in moisture. And as we know, moisture is going to lead to corrosion, and that is when the problems start to actually begin. So at the end of the day, we want to have this end-to-end system that has the proper data collection procedures and data collection tools. And at the end of the system, the results are going to be recommendations as well as metrics for early age preservation activities. So now what we are working on, that is the whole goal of NCHRP program, and that is what pretty much our advisory committee is actually doing as well, is to ensure that this project and the results are field applicable. I mean, we don't want the results to turn into, for example, an article published in a journal and go sit somewhere like on a shelf and start getting dust. So field applicable, field applicable, field applicable is like the primary goal of this project. That is why we are working on an automated data collection solution and automated data processing solution, so that we don't have like any human taste or bias, whether it is in the collection of the data or in the processing of the data. We want to make sure that we have minimal to zero lane closures when it comes to collecting data for this purpose, so that state DOTs can start using it. And then at the same time, it is cost effective and inexpensive. So how are we doing this is pretty interesting. As I just mentioned, most, I guess, the most important piece of this research, or the primary driver, actually is focusing on surface cracking. So we start by identifying the candidate bridges and conduct our automated data collection at speed. Again, speed has been like a primary focus of this, and our data collection speed right now is around 45 to 55 miles per hour. We conduct our surface imaging. We pretty much using the data collection system take pictures from the surface and conduct what we have for now called it like hairline crack mapping. And with this system and the capabilities that we actually developed for this research, we are capable of finding cracks as small as 4 mil, which is around 0.1 millimeter. And just for comparison purposes, like a hair strand is like a little bit larger than that. Right now, we have 5 categories of cracks. Nothing pretty much on this research is set in stone. We are open to see what the data tells us. So for now, these are like the 5 categories of crack width that we've actually developed. Once we finalize the first round of data processing, they may actually change, because we're going to see that, hey, we see like a lot of correlation with crack width in a different category, and for example, the deck taking in moisture. So everything can pretty much change, and that is the flexibility that we have here. So out of the surface imaging and crack mapping, our crack maps, crack density plots, and tabulations are automatically generated. Next, we actually do another round of testing, and we measure the moisture retention and moisture ingress on the deck. We use ground-coupled GPR as well as air-launched GPR antennas to actually do this. And what we are actually doing here, which is pretty much a little bit different with how GPR is conducted these days, is actually 2 ways. One way is pretty much, we drive the data collection vehicle that is equipped with GPR antennas on the surface of the deck. The other way that we are actually doing it is we spray the surface of the deck with water. So we expose the deck to a controlled amount of moisture. And then we go back, within like certain periods, hours, days, and sometimes weeks, and then take GPR reading, because we want to see the amount of water that we actually expose to the deck, how that is actually being kind of penetrating the concrete, and where in which areas it is actually being retained and for how long. And the technique for data processing that is called time-lapse GPR. So it's like pretty much like a GPR that is like happening in different intervals. And the last technique that we are using is like thermal imaging or infrared imaging of the surface to bring in the surface kind of water evaporation rates into the equation as well. So now, as you already guessed, we combine all the tabulations, do data fusion, and a certain mathematical formulation between all of the results that the data generates for us to get the following 3 things, which is bridge deck vulnerability plots that I just mentioned. Vulnerable location is an area of the deck that is perhaps like having hairline cracks or like larger cracks, and it have started to take in moisture, and that could start happening just in a few months post-construction. Vulnerability index, or like indices per span, regions of interest, or like per the whole deck itself, just in case we want to have like certain amount of budget and then divide it between different bridge decks. We want to have like a unified kind of index for each one of our bridge decks, so that it's gonna give us like a educated, I would say, answer and educated guess on the need of a recently constructed deck for preservation activities. And at the end, we want to determine the relationship between these indices as well as ideal preservation activities. And for that, we are going to use a lot of the knowledge that different state DOTs, both the ones as part of our advisory committee or any other state DOT who is interested to join us in this research. So an image of the data collection system that takes care of the work at high speed. The imaging systems, surface imaging as well as infrared imaging is up top on the rear, and the GPR antennas are in the front. This is one of our data collection vehicles that we're going to be using for the purpose of this research. And if you want to take a look on how it works, it's like pretty simple. We pretty much drive the vehicle on the surface of the deck, and all the sensors are doing what they're supposed to do, and done. We actually collected the data. This is another system that we actually retrofitted for the piece of the research that requires spraying the surface with water and conducting another type of GPR that on the system, actually the GPR takes place in a ground-coupled fashion. So each one of those sensor trays that you actually see on the ground, they are equipped with kind of precise water spray nozzles, and we control how much water is actually going out of each one of those sprayers. So with the system we drive on the surface, we kind of expose the surface to whatever amount of water that we actually want, and then we go back and again using the same system conduct our ground-coupled GPR. And the system is like pretty fast. We can conduct our GPR surveys at speeds around 5,000 square feet per minute. So a few images, kind of if you want to look at like the resolution of the images that we actually capture at speed. On the left, you're going to see like a zoomed out view. On the right, it is pretty much zoomed in at 95%. We can even like go a little bit more in. The images, as you already guessed, got to be high resolution enough so that we can find cracks as small as 4 milli-inches. Some of the presentation of the results, the surface cracks are color-coded based on the different sizes that we actually determine. Better shape on left, like pretty much worse shape on right, but this is like a good kind of graphical representation of how the cracking would look like. And then side-to-side comparison of, for example, crack maps versus like any other maps that we have, for example, moisture retention or moisture ingress maps. So as I just mentioned, our main focus is field data collection, and a lot of it, we want to actually see what is it that the data tells us, rather than us like formulating a theory based on, for example, research and kind of go ahead and follow it. That is why we are working with like different state DOTs. We are looking for volunteers to actually add more newly constructed bridge decks to the basket that we have. Our field data collection actually started in September, pretty much a month ago. We conducted our first round with Iowa DOT in Iowa. We collected, I guess, data from 10 recently constructed bridges, if I remember correctly. Indiana is actually next. We are going to be doing 6 bridges in Indiana for this research. And after that, Texas DOT has given us a few newly constructed bridges too. That is for 2023. For 2024, we are budgeting, the work right now. Delaware DOT, Vermont Agency of Transportation, Virginia DOT, PennDOT, and Wisconsin are some of the candidates that we have. A few of them are already budgeted and confirmed, and we are working on budgeting for a few of the other ones. So if you folks are interested, to join us, any of, the state DOTs in the audience, if you have like early cracking problem, or if you would like to kind of be appraised of the results as we are moving forward, because it's going to take some time for them to get published, or if you have like bridges that you would like nominate and give them to us for data collection, I mean, we have still some budget remaining. We can see if we can actually fit you in the project schedule. Please reach out to me or any of the members of the advisory committee. Philip is here. Joe is actually here as well. We would be able to actually, look into, the candidates and add them to the pool. And, my information is there as well. You can reach out to me directly as well. That is pretty much it. So if you folks have like any questions, I would be glad to answer. Thank you.
So I note that you, thanks for that. It's a really interesting presentation. I note that you're going to do Indiana DOT decks, and we just heard from Indiana about that E5 internal curing decks. Are you going to do those decks and normally constructed decks for Indiana, or do you know now? Have you made that determination?
Well, we have picked, we actually received a list from Indiana DOT from like a few of their newly constructed bridge decks, but I'm not sure if any of those bridge decks are part of that list or not. But, we can actually go back and check out the list and maybe like pick a few of them. That would be actually an interesting study that we can do, because we're going to go there in like 2 weeks, I guess, from now. So that can be something that we can consider.
Any more questions?
All right, thank you very much.